sets that I have in there on I teach multivariate analysis. Because it'd be too much to enter. 44 variables, 369, but they understand it. You see how it's in there. At that time, they understand a lot of the things. Okay, we're going to go ahead and start then. Okay, last week, what we did is we were looking at the underlying dimensions, the underlying factors that these 44 items were tapping. They had been administered to 369 women in leadership or CEO positions in companies, hospitals, organizations, etc. And so they want to now when we look at these underlying dimensions, what we're looking at is construct or theoretical validity. There are 4 types of validity. Validity is the extent to which a measure or scale measures what it purports to measure, what it claims to measure. And of course, you have content validity, predictive validity, concurrent or diagnostic validity, and then theoretical or construct. Okay. Factor analysis is the most frequently used method to establish theoretical or construct validity. The underlying dimensions that are loading, that you're tapping or extracting. And if you noticed, you noted on that one handout that we stapled up there in the corner, we remember previously, not the last week, but the week before, we talked about item distributions and how that can impact things later in terms of the psychometric properties of the scale. And when we did that, we noticed that the first item, helpful, didn't load on anything. Okay. Now we tried with an eigenvalue of 1, and we got 12 factors. Well, that's an awful lot of factors. You're striving for parsimony, for one thing, in science. You're striving for parsimony, and then you also, if they make theoretical sense. It is possible it could be 44. Okay. But when we went to an eigenvalue of 1.5, we noticed it dropped down to 5 factors. But when we looked at item number 1, helpful, to the extent that I'm helpful, from strong, let's see, what it was, the scale ran from I'm never helpful to always helpful, the 7-point scale. To never helpful to I'm always helpful. Okay, and that one didn't, because of the item distribution, didn't load on anything. Also, it would not, its discrimination index, well, it's discriminating between among the 369 people in terms of the item dealing helpful, didn't discriminate because of the skewness of the data. Then also your discrimination index would be extremely low or of no value. And then also your Cronbach's alpha, where your reliability coefficient is going to be very low. It's going to attenuate that. So each one of the item distributions and the aggregated item distribution, they have cascading effects on all the psychometric properties. And so that's the reason for it. And I know there's a number of dissertations and faculty research projects that the reason we're not getting anything is because of the item distributions. And so that's what we're working on. But anyway, today what we're going to do now is, so we ran it last week with an eigenvalue of 1, and we saw that that didn't really give us as much parsimony as we wanted. So then we moved the eigenvalue to 1.5. And I think that it converged. I think if I had to change the number of iterations, but I think it converged. I don't know if I changed it to 100 or not, but it converged within, I think, less than 25 iterations, which that's nice. Okay. When you have to go up to have a lot of iterations, you've probably got troubles in your data set. You've got measurement error, a lot of measurement error. So a lot of noise in there. So today what I wanted to do, you have that there, and on the last pages, I think 25 and 26, you see that the 5 factors. And we need to look through those items to see which ones load, okay, and then which ones cross-load. In other words, they load on more than one factor. We need to delete that because that item is ambiguous. In all your validity and in a psychometric theory, we want our measure to be tapping something pure as possible. If it's measuring reading, we want it measuring reading. We don't want it measuring depression, anxiety, stress. We want it measuring reading achievement. If it's measuring anxiety, we want it measuring anxiety. We don't want it measuring everything else in the universe. It's easier to interpret that way. So that's the reason. That's the reason we use Verimax rotations to get the pure underlying dimensions. Okay. We need to look through for the items. Well, let me go ahead now and run this so we have it. We have it up on the screen so that we can have it recorded. So I'm going to go ahead and run it again, but setting the eigenvalue at 1.5 rather than 1. Okay, go to Analyze. Then I'm going down here to Dimension Reduction. And with factor analysis, exploratory factor analysis, that's what you're trying to do is variable reduction, data reduction, variable dimension reduction, or whatever it is. Because it's highly unlikely. You're not measuring 44 different phenomena. You know that, hopefully. So. And now I'll need to enter. So what I'm going to do is going to click on this one, because we don't want subject. And I'm going to go all the way down here to the bottom. And then I'm going to press on Shift. Now I'm going to click on Gentle. And you notice it highlighted all of them. So I can move them in one at a time. If you only have 5 variables, I just do it one at a time, but it's faster. But when you have 44 of them, it's easier to do it this way. And then the descriptives, we're not going to be really interested in that. We could get the correlation matrix, and I do sometimes, in terms of exploratory, do an intercorrelation matrix table. But not today, okay? Then extractions. Now, I'm going to go ahead and put the scree plot on here again. And I'm going to change this eigenvalue here to 1.5. Because last week when we tried it with just 1, we ended up with 12 factors. That's 3.66 items per factor on average. When we switch to 1.5, we got 5 factors, and so now we get an average of 8.8 items per factor. If it was on average, it won't work out that way, but if that's so, it gives you a little rule of thumb. And you're striving for parsimony, and we also are going to have to look to see if these factors make sense. Okay, if they have their theoretical sense and their in terms of comprehending, do they make theoretical sense in their loading? So now I'm going to click on Continue again here. Rotations, I'm going to use, again, we're going to use Verimax, which gives us independent. This is the one that's most frequently used, especially in psychometric theory when they're trying to develop scales or measures of personality, attitudes, interest, looking at organizational climate, whatever it might be, because they'll give us orthogonal factors and maximize the loading on columns or the items, and we're treating the items as variables in this situation. Quartermax would maximize the loading on rows. And there's sometimes, if you're looking at personality, certain things, your scale looking at personality things, you might want to use that. Equal max will maximize the loading on rows and columns. Okay, this is a probability one. This one here is non-orthogonal. The reason we're doing this is so our factors are independent of each other and not correlated. So we would not use, I have used it sometimes with biological research, but not in educational or psychological research ever. So the Verimax is the one you're going to be most often using. Then I'm going to click on Continue again. Okay. The scores, I don't want to save them. Now, a lot of people want to have the scores weighted by the factor. I'd rather have the regression analysis do that. Then I'll show you today how we're going to analyze the profile of the people, okay, when we get through with this. and then continue, and then options, and I'll explain and discuss it later, the reasons for it. And again, we don't care about excluding cases or anything like that. And then continue. So I'm now ready to go ahead and click on OK. I'm going to click on OK, and it'll go ahead and do the factor analysis with just the eigenvalues set at 1.5. I'll click on OK. And we should be getting the same results as we did last week. We got serious problems if we're not. And now I'm going to try to scroll up here a little bit. Scroll down here, and so now with 5, okay, now this is principal components analysis. It will do principal components by default. The only reason we use principal components analysis, it tells us how much of the total variance is explained given the eigenvalue and the method of rotation. And we're explaining 42% cumulatively. See where over here I got 42.5. Now we'll be able to find the same thing out when we look at the rotations, okay? But that's what it will tell us, how much of the total variance we're explaining. We would like to be at a little bit more, but that's not bad, okay? We'd like to be in the 60s if we could. Okay. See here, you can see it cut off, and here when it's at the eigenvalue 1.5, right in here, here's 6, and then anything below 1.4, see, it doesn't show up. Now the scree plot is a good way to visualize it. Here are the components, and it will always give you back the same number of components or factors as you got. Okay, it'll give you back 44, 40, 43, 44 of them. Now, here's the eigenvalue. Now we can see here that factor 1 is loading, has the greatest loading, do you see? And then we got here a factor 2, factor 3, component. I'm sorry, component. And here the eigenvalue of 1.5 would be probably someplace right here. So 1, 2, 3, 4, 5. You see how I marked right here 1.5? And that's pretty much when then the elbow kind of flattens out. So these factors are really probably pretty nominal in terms of the data set. So that's one reason, that's one way of visualizing it. You can also go back up here and look and see how much, okay, the first factor, how much variance it's explaining, and then also cumulatively how much you're explaining altogether. So you got 13 with the first factor, the percent, 9, 7.76, etc. So in terms of the factor here, you can see the percent of variance explained. Here's a cumulatively where they've added the 13% onto the 9%, and you get 22% with the first two factors. Do you see what I'm doing? And then the third factor, etc. We're using exploratory factor analysis, and it's a descriptive procedure is what it is. It's not there's no hypothesis testing. And see, in psychometric theory and data theory, I worked in it for decades. There's never a hypothesis testing except in confirmatory factor analysis. And again, this is a scree plot. Now here's a component matrices. Again, this will not be interpretable. So we need, as we talked about last week, we need to do the Verimax rotations. We'll refine it and make it clearer. We'll have more of your items loading only like high on one factor and maybe low on the others or something. And that's what you're wanting. You want a simple structure. A simple structure is where an item or a variable loads on one factor and no other factor. It's low. It's high loading on one factor and low on all the others. Now, I know some of you had looked at these. We go down here to where the Verimax is at. Let's see. Here's the Verimax. Okay, here's the rotated. This is one we're going to interpret. This is the one we're going to interpret. The rotated component matrices, this is actually using Verimax rotations. Now, as we already have noted previously, and we discussed 2 weeks ago, item distribution has a cascading effect on all the psychometric properties, from discrimination index, true variance, and validity. It's going to, so if your item distribution, and the reason, as we talked about, you want your items to maximize the detection in individual differences if you're trying to measure stress or anxiety or reading achievement or organizational climate. You're assuming that there are individual differences. Not everybody's exactly the same. If they are all exactly the same, there's no reason to observe them or measure them. Just write all their names and just write 150 pounds, 150 pounds, 150 pounds. 5'9", 5'9", 5'9", because you just said nobody is 5'10", nobody's 5'8". And that would be a boring world. Anyway, so, and then the other reasons, if your data are continuously valued and normally distributed, and also they'll aggregate for that scale into a scale that has continuously valued and normally distributed. Now, an item is very difficult to get it, really, but when you aggregate, you'll approximate a normality of distribution. And the other reason is if your data are continuously valued and normally distributed, by definition, you have interval scaling level. Okay, that's the second reason. First reason is you want to maximize your detection of individual differences. And the third reason, and probably even the most important, if your scale is continuously valued and normally distributed, your true variance, your reliable variance, and your measurement error variance will not be correlated. And you can't have them correlated, or you really got a messed up scale. So let's look here. We looked at item 1, and we noticed what? We first set the eigenvalue at 0.40. Anything greater than 0.40, either negative or positive, we were going to go with. Okay, now sometimes you'll work with these data, and you'll need to change the eigenvalue maybe to 0.45, okay, to make it theoretical and be comprehensible. Okay, it's not comprehensible otherwise. The first item here we'll notice helpful, and I'm always helpful, I'm never helpful, so to speak, so how they marked it. That, because of the item distribution, now that probably had a little bit of a social desirability, because I think it was highly negative skewed. And on this 7-point scale, always. Okay. So most people were marking 6 and 7. I'm always helpful. Okay. Okay. Well, that's how they perceive themselves. But they also, that's a social, that might be a veracity item in a sense, okay? But that would probably eliminate all 369 subjects. But anyway, so, and now then, self-reliant, let me see, it loads on what? Factor 4. And fortunately, it does not load on 5, it doesn't load on 3, it does not load on 2, and it's low, very extremely low. It's below 0.40 on 1. So we're going to keep self-reliant. So you'll circle with red. You're going to need to keep tabs of this, because I'm going to be asking you to give this to me when I start to aggregate these, okay? And when we do also recoding, because we may have some load negatively. We want to save the item, keep it on that scale, but we're going to have to go recode it. Because if you have 8 items loading on a factor and 7 of them are loading positively, okay, that's good. They're going to have additive effects. If we leave that other one and it's loaded in there negatively and we aggregate all 8 together, that one is going to have a subtractive effect. You don't want that. You want to either you have them all additive or all subtractive, but usually all additive is what you're looking for. So now let's look at here, defends beliefs. Okay, now that to me looks like it's a 0.49, and the other on factor 2, factor 3, factor 4, factor 5, it's just nominal loading. So I will circle defends beliefs. Whoops, too far here. And then the next one, yielding, it doesn't load on any factor, just like item number 1. So we're going to need to cross out item number 1, helpful. We're going to need to cross through yielding also, también. And I'm sure if we go back and look at the item distribution, we're going to see an item distribution that's probably highly skewed. Skewness will impact things more than kurtosis. Deviation in terms of the density of the distribution, the height, the ordinate of the distribution does not impact things as much. Okay, now cheerful. Cheerful, okay, now that actually loads on factor 3. And it's pretty clear. See, it loads virtually not at all on 1, not on 2, not on 4, not on 5. Okay, independent. Ooh-dee-doo-dee-doo-dee-doo. Well, we got a problem here. Look at here. 0.43 here and a point what? 5.1 here. Independence. The problem here isn't that, like, it's different than from items 1 and 4, where they didn't load on any factor. Here they're cross-loading. They're loading on 2 factors. They're cross-loading. And if we leave it in there, any interpretation, any analysis, a regression analysis, profile analysis, any kind of comparisons or relationships we want to look at with utilizing this scale, well, we will be ambiguous, and you don't want that. Again, we want it pure. So this one will be deleted. Now let's look at the next one, athletic. It doesn't load on anyone, so that one's got to be crossed out también. Okay, it doesn't load on anything. Now shy, we can keep that one. You see, it's a negative 0.44. So circle that one in red. However, before we can do any aggregating, I'm going to have to go back and do some recoding, as we do, so that when we're aggregating, we all have additive effects, and we don't have anything included that's subtractive. Now, assertive looks like it loads on factor 1.
When you say recoding, do you mean you're going to reverse?
I'm sorry, you have to speak up a bit.
When you say recoding,
Yeah, in a little while, I'll do that. In order so we can aggregate that item, it's loading, and we want it to load. It's loading, okay. Do you remember last week or the week before when I showed you that one where this one item, and in a sense, it's almost like a discrimination index on that given scale. When we had that scale for 5-year-olds, and they were trying to measure emotional disturbance or mental health, and they had a total score of mental health with a lot of items. Then they had this one item with 6 items on it, okay, where they showed pictures to the child, and they had to point to the passive one or the proacting one, and so they were actually pointing to the passive one, the mentally healthy ones, okay? The ones that weren't so mentally healthy were pointing to the mowing the lawns, painting the houses, swimming across the swimming pool, etc. And so we kept the item. It was working, it was discriminating, but we had to recode it. So in other words, if they pointed to the passive child, all 6 pictures, they got a score of 6, okay? And then if they pointed to, like, 3 out of we got a score of 3. But we recoded because we were thinking that proacting, which might have been true for adolescents or adults. But given that stimulus, that item, it was measuring for 5-year-olds, but not in the direction we were thinking. So we kept it. So we had to recode. I'll show you how to recode it a little bit. Okay. Now, assertive also, so you'll circle that one. Strong personality, you want to circle that one. Forceful. Now, affectionate, that would be on what? Factor 3, right? And then flatter, factor 3. Loyal, factor 3. Let's see, analytic, I think that's what that is. It doesn't load on anything, right? Cross out analytic. Okay, it fails to load on any factor. Okay, Now, sometimes it won't be just the item distribution that's messing you up. You may have an item that's maximizing its contingency valued and approximating a normal Gaussian distribution, but it doesn't load on anything because it doesn't measure that. Okay? Because it doesn't measure that. It might measure something in the universe, but it's not among these 5 factors. Okay, feminine doesn't load on, you need to cross that out. Okay, sympathy, that would be factor what? 2, circle that one. Moody, 4. But now again, it's loading negatively, we're going to have to recode that one. That's another one we're going to have to recode. Sensitive, factor 2. Understanding, factor 2. Compassionate, factor 2. Leadership ability, factor 1. Eager to soothe hurt feelings, that's factor 2. Willingness to take risks, that would be what? Factor. But now we need to think about this a minute. Because see, it loads a 0.399 on factor 1. That'd be rounded up, that's a point what? I think, unless we desperately need an item on factor 5, we might want to cross it out. If you really need an item on factor 5, we may go back and save it and circle it and load it on factor 5. Because it did load a 0.48 on factor. Because you have to have more than 2 items to have a factor. But not only that, you want more than 2 items so that you have some reliability, some stability, you have some true variance, reliable variance. So put a question mark beside that with me. We'll see what we have here. Okay, now makes decisions easily. Again, do you see factor 1 and factor 4 is loading on both? Cross it out. It's ambiguous. Self-sufficient, factor 4, pretty clearly. And that's what you want. You want a simple structure. Conscientious, factor 4. Dominant, factor, okay, that would be dominant would be factor 1. Masculine, what? Nothing. We need to cross it out, right? Okay, willing to take a stand, factor 1. Happy, factor 3. Soft-spoken, okay, that loads actually on factor 1, but that's one we're going to have to recode. You see it's negative? So we're going to recode it. It's called soft-spoken. Okay, then let's see. Warm, that's 3, right? Ooh, it's got to go. It's got to go. Cross it out. It's too ambiguous. It's cross-loading. Truthful, what? Got to cross it out, right? Doesn't load on anything. Isn't that interesting? CEOs. Remember that book you were telling me about, Angela? I think I got that book at home. Okay. Tender. Again, do you see it loads on factors what? 2 and 3. We need to cross it out. Now, gullible, it loads really on 4, right? but it's a little bit on 5 too. Oh boy. What are your
So
thoughts?
is it too close to 4? Is that one too close to 4?
Yeah, I'm thinking, yeah, it's pushing.
But if, because the other one's negative and you'll recode it,
If we recode it, we could recode it and go back and run the factor analysis, and it would load on here. If I recoded just that one item, it would still load on factor 4, but instead of being negative, it'd be a positive one, a positive 0.473. If you want to, I can demonstrate. You can go back and refactor analyze it. It'll load exactly the same amount on the same factor, but it'll be positive.
but the one that's masculine earlier. Yeah, it was 0.388 and we crossed it out.
We crossed it out, right?
Yeah, and that, because that was the highest number.
Yeah, and this one here is also, see, it's cross-loading here in a sense. It's marginal. We'll see if we're desperate on item 4, a factor 4 for an item, we may have to come back and put it in there. But okay, act as a leader, that's on factor 1, that's pretty clearly.
Then should we also put a question mark for the masculine?
Pardon?
Should we also put a question mark for the masculine? Yeah, because we crossed it out and it loaded on factor 1.
We could, yeah, we could, but I think we're going to have enough items on factor 1 already, I think. So we don't need, factor 1 doesn't need any more items. Where we're going to need items probably is on factors 4 and 5. Okay, then we're gullible, act as a leader, factor 1. Childlike, okay, factor 4, but we're going to have to recode. And make sure, let me know that, so we have to do it. And then individualistic, 1. Use foul language, that's bad words. It doesn't load on anything. Huh? Okay. Love children. Oh, wow. Doesn't load on anything. Okay. Competitive. Okay, look at the problem with that one. It loads on 1 and, oh, boy. It's ambiguous. It's cross-loading. So we need to cross that one out. How about ambitious? 5. Boy, finally 5 got a factor, an item, right? And then if we look here now, gentle, what happens there? Cross-load, so it has to be crossed out. So you've been doing this. I've been not doing this. So I'm going to be consulting with you all the time on this. Okay. So now we're going to go back to the original data set. And how I do that for the recoding, for the purpose of recoding, and you're going to have to let me know which ones it is. Okay. And when we aggregate those, we're going to have to recode them. And remember to add in those and not the ones. Unless I delete them. I could substitute them in, I guess. That would take care of it. So I'm going to go, well, I can go right straight here to transform. I can go to transform, then go to compute. Let me see. No. Right here. Okay, I'm going to recode the same variables, but I wonder if I should recode one and make it totally. Yeah, give it a new name so you can see what it is. Same or different variable. If I do it in different variables, it's going to put it on the very end. I think I'll do that so you can just see what happens, okay? So now then, there's one, the first one that had a negative loading. Which one was that? Huh? Was it yielding? No. Shy. Okay. Okay. Now we're gonna. Okay, old and new. Okay. How did I do it last time? 7. Start with 7 and made it a 1. That doesn't make any difference. Pardon? Oh. Okay. Well, it doesn't make any difference. You get the same results, yeah. Okay, and then this one's going to be 3 and 5, right? And now then we're going to go 7 and 1 and 6 and 2 and then 5 and 3. Now try to continue. Let me see it. Copy all values. Let's hope this works. I'm going back to the original. Here it is. You know what I failed to do? 4 is a 4 and 4 is a 4. See here? Huh? Look, it's creating. Let's go back on the old shy. See this 4? It made it missing, so I got to do both. 4 is a 4. You used to not have to do this. This is only with the new one. With the old SPSS previous, like SPSS 19.0, 18.0, you didn't have to do this. Now you have to enter the 4 too. So that's a boo. Okay, I'm going to have to make this a shy, but I'm going to name it, let's see. Make it new shy. want to, you're going to have to add on new shy corrected. We're going to have to change it some way. New shy correct. New shy correct, okay? Now let me get all these out of here. Okay, now then, what do we start with? With 1 or 7? Okay, 1, and then 7, and then 2, and 6.
If you use the new shine to correct it, then you don't need to do all of these.
Yeah, but I'm going to, it's going to create another new variable. It'll create a whole new variable. 3 and 5. Okay, should I do a 4 here now and a 4? And now then, the next one's going to be a 7 and a 1, right? Okay, then it's going to be a 6 and a 2. And then the next one is going to be a 5 and a 3. Now that should, I don't think we have to put in another 4, do we? I don't think we have to do it again. So now there shouldn't be missing data. Okay, so I'm going to click on continue again. Okay, and then I'm going to, and now I'm going to go back to the original data. Okay, here's shy, the original data, right? And then remember this was a 4 here? Now we scroll all the way over. It didn't show up the corrected one. It just did it the same. What? See, it's 7. It did recode 1 to 7, but now it's not missing. It's in here. But it should be saying new shy corrected.
You didn't hit the change.
Oh. But it did correct it in here.
Yeah.
But it won't be permanent, right, until he
We're going to be adding
permanently
these up.
changes.
How many were negative on that factor?
Moody is negative. Oh, on that one?
How many?
Well, shy is negative. Moody is not on that factor. It's on another factor.
Yeah, we don't need to worry about that right now.
That's 3. Factor 3 was negative for shy. Is that what you're asking?
Oh, no, just factor 1. How many were
Oh,
loaded?
how many were negative? Just shy, I think.
Just shy.
Oh, soft spoken. Soft spoken on factor 1.
Fact, soft spoken was
Yes.
negative 2. So we probably go back and should redo that one too. Okay. New.
Soft spoken.
Let me go back here to transform again. Recode into different variable because that's what I was doing. And this time we're going to. What was the name of it again?
Soft spoken.
Whereabouts is that at? Is it toward the bottom?
Well, it's kind of like in the middle. On the, from the bottom, it's right there behind, under happy. It's the very last one right now where you have it.
Oh, here it is. Okay. Okay. Okay, now we got to go back and change all these values. And I better take this. I don't think I can just leave it. I wish I could just leave it and not have to redo them, but I think you need to redo them. You think it'll work? Okay. Then just leave them alone then. And see if it works. Okay. Boy, if it does, it's going to be handy, dandy, dandy. Okay. Go back to the data. There it is at the end. Do you see it's at the end? Okay. Okay, how many other ones do we have to do now? We can do them pretty fast by just doing it that way, I think.
Do you just want to do factor one?
No, we're going to go ahead
All
and
of
look at this. Is there any load negative on a second factor?
Yeah, Moody loads.
Moody.
Loads negative.
Moody loads negative. Okay.
What were the values? It was 1.7, because I remember.
It'll show up in a minute. Okay. Now it's Moody. Where's that at?
Is by sympathy and sensitive. It's like in the first list.
Up toward the top?
It's kind of in the middle.
If I had my glasses on, might help. This will help a lot, 100%. There's Moody. Moody, here we go, Moody. Okay, the name's going to be New Moody. No, I didn't even, did I type? Yeah, I guess I didn't. I thought I had an O. Change. Okay, now old to new values. And we can just go ahead and click it in. And if we look at the data, it should be in here. See New Moody?
Yep.
Here's New Moody. So we recoded. Now, was this on the second factor, right, Angela?
Moody was on the fourth factor.
Oh, how about other was on the fourth factor? How about on the second factor? Any loaded negatively there?
No.
How about the third factor?
No.
So this was the other one. Now, how about on the fifth one?
Well, we have more on the fourth factor.
Oh, okay. Which one are those?
Okay, we got a question mark by gullible because it's loading negatively on factor 4, but it was 0.388 in factor 5. So we put a question mark.
Yeah, it's a big cross loading there.
Yeah. So then the next one would be childlike, and it's negative on factor 4.
And that's the same thing as Moody, right? Same factor.
Yes.
Why don't we just cross to save time? Okay. Go ahead and cross that one out that we thought was cross loading.
Gullible?
Because a 0.388 in the other one.
Yeah.
Okay. So now the other one that loaded on 4 was what was it?
Childlike.
Childlike. Okay. Now where was that at?
That is towards the end, yeah.
Right here. I got to get this one out first. There it is. Now the new name is going to be New New Childlike. Okay, I'm changing that one. And it should be on here. See, new childlike over here. Okay, so that was 4, right? There were. So we changed on item 1. We recoded 1. On factor, I'm sorry, factor 1 we recoded 1. On factor, which one factor was this? So we recoded 2 on factor 1. And we recoded 2 on factor 4. Moody and childlike. So we recoded 2 of the items on factor 1 and 2 of the items on factor 4. Okay, so now all of them will be, do you see, if I went back and if I had more time, I'd go back and demonstrate to you, you get the same numerical value and it would load positively. But anyway, now we're ready to do some aggregating on the factors, okay? So you're going to have to be looking at, on factor 1, we're going to create a new name for it. I'll call it total assertive or something like that. I'm going to call it total assertive or something like that. Because that first factor looks like an assertive characteristics, right? If you look at the theme throughout in terms of a temperament or personality, would they tend to be assertive? Look at the ones that load on factor 1. What's the theme that you see going throughout that? Do you see a theme? What do you want to name factor 1? What I'm asking is, what do you want to name factor 1? Assertive, okay, for right now. If we think of a better name for that factor, that scale, we will, okay? So what we're going to do now is I'm going to go back to transform again. This time it's going to be compute. And I'm going to call this total. You can't leave any spaces here, okay? Total assertive or something like this, okay? You see what I did? Now, you're going to read to me the first one that loaded on there that was positive, okay? Helpful, didn't I know? Okay, defends beliefs. Yeah. The very first factor going down. The very first factor going down. And you circled the ones that are greater than 0.40. Defends beliefs. Oh, right here. Okay, thank you. Okay, do you see what I did? I clicked on this. I'm going to move it in here like this. Then I'm going to click on plus. Now then, what are we going to, we need to go to something. Well, yeah, and because of if there's a negative, I got to do the negative. I got to go back to the one that's recoded. Assertive. I'll back up. Oh, here it is. This one. Okay, and then what's the next one? Okay. Now you notice I'm putting a plus each time between them, right? And this is like a little calculator here, a little adding machine. Now what's the next one? Forceful. Okay, it goes in. Plus, what's the next one? Leadership ability. And what's the next one? And what's the next one?
Willing to take a stand?
This one here? Okay. And what's the next one? Pardon? There are a number of them loaded on this one, huh? You're kidding me. Okay, what's the next one? And the next one?
Well, do you want to add the new shy and the?
Yeah, we're going to put it in, yeah.
Okay, then next would be new shy.
Okay, new shy right here.
Yeah, cross-loaded. And then new soft-spoken.
A new,
Shine corrected.
huh?
Should be the new shine correct. New shine correct.
I don't think he has that one on there because
It didn't show up. It didn't work out. It might have for you. You probably clicked on the right one. But ours corrected itself. So. Okay. New. Now all I've done is new shy. Was it new moody too?
no, it was new soft-spoken.
When you use new shine,
I didn't put in new soft spoken yet,
Yeah, that's the next one.
and that's it.
That's it.
if you use new shine, that missing data is not going to be processed.
Yeah, I should. When I clicked on the original data, it was there.
Yeah, he loaded it with a 4 in there with new shine.
Oh, I see.
Should. Okay. Anyway, now what I'm going to do, you don't need to put equals on here. I'm going to click on OK. And if we go back and look at the original data, this one, see over here? See that total? That's all of those aggregated on that scale, on the assertive scale. There were 11 items, 11 altogether out of the 44. Yeah. But not right yet, but we are, yeah. Yeah, we're going to. You're right. In order to do a profile analysis. Now, to do regression analysis, you would not. With regression analysis, you can leave it in original metric because on the derivations in regression, when you get your multiple regression coefficient and your standardized regression coefficients, they'll be all transformed into z's, both in terms of the criterion or dependent variable, and all the independent variables are predictors. So you can leave them like this. But if you want to do a profile analysis, they got to be in common metrics or common calibrations, or it won't work. Now then, we can go back, and what was the second factor? Can anybody look at the second factor? What was going on with that one? Sympathy? I'm going to transform, then compute variable. And now this time I'm going to take out assertive. Let's see. Delete. Then I have to take out all of these. Delete. And now then, what was, this is going to be total. Do you want total empathy? Empathic? You want empathic? Did I have it spelled right? Capitalize the E, okay. Is that better now? Okay, now, you're going to have, I don't have these data in front of me. You've been circling with your pins in red, remember? Huh? Second factor, second factor. Oh, you want sympathy, okay.
No. Down your first.
Oh,
First,
okay.
sympathy. Yes. Down under feminine. Yeah, right there.
Okay. Put that one in, now plus. Now which one? Sensitive? Now which one? Huh?
Understanding.
Now, what other one loaded? They all had a positive loading, right? What's the next one? Huh?
Oh, compassionate, you didn't get compassionate. Understanding, compassionate,
Compassionate.
and then eager to serve.
This one here? Leader? No. Eager to. Yeah, that sounds bad.
That's the last one.
Well, that's the last one. I got to get this plus business out of here. So there are 1, 2, 3, 4, 5. Remember how many are loading on there because we got to do. Okay, now so I'm going to click on OK here. And if we look back here at the data again, we're going to see it over here. Now, it's based on what? 5 we entered. This one was based on 11. And as Dr. Shin just mentioned earlier, we're going to, in terms of profiles, we're going to have to average them. But right now, we're going to do all 5 factors first. Okay, I'm going to go back to transform again. Compute. I want to take out this total empathic, or I'm just going to take out maybe this back to total. And then I have to take out these. We're on the 3rd factor now. What was it? What's the theme that's running through the 3rd factor? Happy? Total happy?
It's like affection, flatter, cheerful, loyal, happy.
A real positive, that sounds like the person I want to be around.
Total positive?
Total positive? Okay. Now you have to tell me though which ones load on there though. Helpful doesn't load on anything.
Cheerful.
Cheerful. I'll go for that one. How about the next one? Affectionate. Okay. And the next one. We're on the 3rd factor now. Okay, now which one? Loyal. It's the 3rd factor.
And then the last is happy. It's kind of towards the bottom. There we go. It's under,
Now, how many loaded on here now? 5. So the first one had 11. The second one had how many? 5. And this one has 5. So unfortunately, the other one didn't have just 5 too. We wouldn't have to do the average. Okay. So I'm going to click on OK. And again, if we click on the data, you're going to see over here. We had total. We got total assertive, total empathic, and total what? Positive. And now we got to go back and do number 4, factor 4. Now that had some we recoded, right? Yes. Okay. Compute. What are we going to call factor 4 though? Total what? What's the theme? Self-reliant, self-sufficient, so be okay, self-reliant, okay.
confident, yeah.
Is that close? Self-confidence?
Sure.
Okay, now we got to take out these, right? Because this was for the other factor. So. Uh-huh. Ego strength. See, ego strength. There's another better word than that. Let's see. Self. Okay. Now, which this is 4, right? Factor 4. Okay. Which one's low on factor 4? Okay. Self-reliant goes in on factor 4. Independent. Did that load? Because it didn't. It was ambiguous, right? Okay. What's the next one? Self-sufficient. Okay. And the next one is this one right here. And then
The other two were the new ones, the negative ones,
okay, new moody. That's one we recoded in, right? And the other one was new childlike. Now, how many are we putting in here? 5. So that's 11, 5, 5, and 5, right? So now I'm going to click on. This is factor 4 now. That's told self-confidence. Self-esteem. The word I was looking for is self-esteem. Well, no, this is fine. We can make that later when we publish it. Gene will change it. Okay. Okay. Now then, again, we can go back, and you're going to see it over here on the end. See? It's right there. Now then, we're going to go back to transfer and do the last one. Oh, okay, that takes care of that. It only has 1 loads on there, so we only now got 4 factors, okay? And given our time frame, there was one we could have put in there. Remember, it was a little bit cross-loading. It was desperate. But see, to only have 2 items on a factor, you don't have any hope. We talked about the University of Texas Pan American using item 11 to evaluate faculty for promotions, tenure, merit, and all that business. Okay, well, we don't want to get into that even with 2 items, okay? Let alone 1. We're not that far off the planet, okay? So let's take here and let's see. I haven't finished it. I did this one already, right? Okay. So we're just going to use 4 factors in our. Yeah, because it showed up over here, right? Yeah, self-confidence showed up on the data. Huh? No, now then we're going to go back and we're going to transform again, but this time what we're going to have to do is find the averages, okay, is like you just suggested, okay? Now, they're all based on a 7-point Likert scale, equal appearing interval scale. But one of these sums, one of these sums here is actually based upon 11 items. If these here would have been, if this would have been on 5, had 5 items too, we wouldn't have had to even do that. But we're going to go back and have to do some average, okay? So we're going to have to divide this one by 11, divide this one by 5, divide this one by 5, and divide this one by 5 to be able to get what we call a common metric, a common calibration. Because then we can see which, in terms of these 369 women in leadership positions in CEOs or in hospitals or schools or whatever it is, in terms of where their profile, where they're stronger or there's no difference among them at all in terms of these 4 underlying dimensions that we have observed or characteristics of women in leadership positions. So I'm going to have to go back to transform business. This is not going to take too long. Compute. Now then, I got to take this out of here. I could go over here and do, but I better go back and do the first one first. I better get this one out too. I'm going to go down to the very bottom one here. This first one had 11, right? So I'm going to make this average or common metric or something like that, okay? Let's see. I'll just use a metric. We'll understand this common metric, okay? Can we understand that? It could be mean, but really you're doing this not for mean business, but you're doing it to get common calibration. COMMON. But it won't hold it all, see. You'll understand this metric, right? Okay, common. Or I won't have to put that total assertive. I can just put common metric assertive maybe, okay? Do you see what I did? Okay, now I'm going to go down here and put in total assertive, like this. Now there were 11 that went in there, right? So this means divide. See where my arrow is? I clicked on there. Now I'm going to put 1, 1. Now watch what happens. I click back over here, and it's going to be, now they're all in common metrics now. Now then what I'm going to do, I'm going to need to do that to all the other three factors, 2, 3, and 4. So we're going to go back to transform, compute again. I can leave this common metric business, but this one now is going to be, and I got to take out this one. This is going to be common metric empathic. Now you said there were 5, right? Okay, so I'm going to hit the divide sign right here. And I want to click on 5 like this. Whoops. Oh, I didn't finish it. Oh, yep, I didn't finish it here. Empathic, right? Okay, now see if it goes. Incorrect variable name. Either the name is more than 3 or is not defined by previous. Oh, okay. Oh no, yeah. Oh my gosh. Thank you. It's got to be total empathic. Thank you. Oh my gosh, did I make a mistake? First mistake of my life. Okay, now divide by 5, right? Thank you. Thank you. Muchas gracias. Obrigado. Grazie. Obrigado. Tack så mycket for Sweden. So Dr. Simonson will appreciate that. Okay, now then. Yeah. You're very good. Thank you. Okay, so now let's see. How many have we done now? Transform. Are we on the fourth one now? Let's see which ones we have done. We done empathic. We got 2 more to do, right? Okay, so this is going to be common metric positive. And now we got to put in total positive divided by 5. And then I'm ready to, do you see, I'm ready to click on OK. Do you see what I'm doing? Am I going too fast now? Okay, I'm going to click on OK. Now we're going to go back, and I think we got another one or two more to do. We did total, now we got total self-confidence. I might just do C-O. F-I-D. They might tell me too many letters. I got too many characters in there. You know what that is, right? Now then, with total self-confidence like this, divided by 5 again, because there were 5 items loaded on there. So I'm click on OK again. Now we're ready to do the analysis. Now we're ready to do the profile analysis on the 4 underlying dimensions to see which dimension do they have greater amounts of this or lesser amounts. The factor analysis doesn't tell you that. Oh, this is a stronger factor, there's more variance. Amounts has got to be told through profile analysis. The factors saying, oh, this factor has more, explains more. That's not stronger. We want to know in terms of those 4 attributes, the strengths and weaknesses in terms of this, or are they actually virtually the same on all 4 underlying characteristics or dimensions? So now we're going to go to analysis. Do you see where I got analysis here? Huh? Okay, analysis. And now I'm going to go to a GLM, General Linear Model. But everything we do is GLM. Even those items that, you know, we got those loadings, those are actually linear combinations. They're not unlike a standardized regression coefficient that you have in regression. Now, if I was presenting at the International Psychometric Theory Society Conference or American Statistical Association, I wouldn't go up there and call them beta coefficients, okay, or standardized regression coefficients, or the linear combination. I wouldn't say that. I call them factor loadings, like we've been calling them in here. But that's what they are. I would call them factor loadings, because the audience would get all nervous. So I just stay with what by convention they refer to. Okay. Now we're going to GLM. We're going to repeated measures analysis. In order to do repeated measures, we're going to have a common metrics. Now we had 4 factors, right? So well, we can just call it factor 1. I'll click 4. Okay, the levels. We're going to have 4 levels. This is repeated measures. It's like pre-test, post-test, but you got not only trial 1, trial 2, trial 3, trial 4. Okay, dimension 1, dimension 2, dimension 3, dimension 4. But we can compare them because now they're in common metrics or common kala. And it's the same subject going across, just like within subjects or repeated measures. So now I'm going to click Add. Okay, now I'm ready to define. You know, I should have named that. I'm going to go back and I want to call it profile, okay? Profile, okay, something. I'm going to cancel. I want to go back and call it profile. I want to give it a name. I'm sorry, the wrong one. I want to give it I'm going to call it profile analysis, okay, of these 169 women in leadership positions. I need to get this out of here. Remember now. Now do it again. Oh, no, I got to do it again. Okay, 4 levels. Add. Now I got to go down here to define. Now I got to put them in. We're going to go down to the common metric ones. See, we got common metric for assertive, empathic, positive, and so I'm going to put in the first one was assertive. Now they're all on the same metric now. The next one it was empathic. The next one was positive. And the next one was what? Self-confidence. You see how we put them all in? Or did I go too fast? Okay, let me start all over, okay? Let's start all over the whole thing. We're going to start all over. Cancel. I'm going back to analyze. You pick me up wherever you're at now. Analyze. I'm going to general linear model, GLM. Linear model. Then I'm going all the way over here to repeated measures. You see how I got to repeated measures? I got to repeated measures. And now then, am I ready to go? Julissa, am I ready to go now? Are you ready with this? Now I'm going to name this, profile analysis. Profile. Okay, now did you get that far? Now we're going to put in 4. I better get this out of here, remember. Now I got to go back and do that again. Profile analysis, 4 levels, right? Now on repeated measures analysis, this is repeated measures analysis of variance, or repeated measures analysis within subjects analysis, general linear model within analysis or within subjects, repeated measures. Okay, it will by default do a MANOVA, a multivariate analysis of variance. It does that by default. And there are 2 reasons for it. First one is to protect you against experimental-wise error rate. Okay? If your MANOVA is significant, you're safe to go to the univariate. Okay? The other one reason would be if we wanted to do some curve fitting or trend analysis. But in this case, we won't, because these are really just nominal characteristics underneath, explaining the women that are in leadership positions. But if all the assumptions are met, the univariate has greater statistical power than the multivariate. if the assumptions of normality of distribution and sphericity are met. You can assume either one of both of those assumptions. Univariate will have greater statistical power than multivariate, MONOVA. Okay, so now then, are we caught up now pretty much? Angela, do you put a 4 here? You did already? Okay, now I'm going to put add. Now I got to go to define down here. Do you see the define down here? Now I got to scroll all the way down to the bottom. Because I have to put, you see, if you don't have common metrics, common calibrations, you'll be getting difference. See, that's the reason the MMPI, the Minnesota Multiphasic Personality Inventory, is so neat for profile analysis, because they already have a metric set up, a reference point of 50 and a unit size of 10. The Wechsler subscales and a lot of your other subscales, achievement tests and standard scores, will have, like the subscales have a mean of 10, a reference point of 10, and a unit size, a standard deviation of 3. So you can do repeated measures analysis already in there, you see. It's already in common metrics or common calibrations. So now I'm going to put in, the first one is going to be common assertive. So I put in, do you see I did that? Now the next one I'm going to go down to is going to be what? Common metric empathic. And the next one's going to be common metric positive. And the next one's going to be common metric self-confidence or self-esteem, the term I like. Do you see how we did? Do you all have them up here like where I'm at now? Okay. Now we're model, I'm not going to care about, I'll show you what it is, but we're not going to modify anything, okay? We'll be using type 3 sums of squares. I'm just going to, that's by default. You can do it to type 2, type 1. Type 3 will adjust for all the parameters involved. Contrast, we're not going to use that either, okay? Let me show you what it is. Plots we're going to use. So we're going to put the profile in the horizontal so we can look at them. And so I took profile and I clicked it over here. Do you see how I did that? Now I got to click on add right here. Then I click on continue. Save, I don't really care about that. Options, we can look at the means, the overall mean. For you that have had the first graduate stat course with me, I talk about bar, the grand mean, you see, and then you put that in there. And the profile means like this. And we want to compare. Now we're assuming the omnibus F is significant. If the omnibus F was not significant, we wouldn't be doing any of this, because there would be no difference among the 4 underlying dimensions of the 369 women in leadership positions, okay? Or there would not be any differences. If your omnibus F was not significant, you fail to reject your null hypothesis, so you're probably in guidance and counseling anyway, because your research hypothesis was not supported, so you feel very, very bad. But we're optimistic that omnibus F is going to be significant, so we're going to go back and detect under what dimension, underlying dimension of this population is in fact different from one other one. So, okay, you want to compare. I don't want to use least significant difference. Don't use it, please. It's not conservative. We'll use Bone-Ferroni as conservative. Then we can put in descriptive statistics like this. Estimated effect size, it's going to be an eta squared. It's going to give you eta squared. Observed power. Now we don't need homogeneity because repeated measures has the assumptions, what you're assuming is normality of distribution and sphericity. Okay, that's what you're assuming. You can make your assumptions. So now I'm going to click on, does everybody have this? I'm going to click on continue. Now I'm going to click on OK. Okay, now here we go. And there were 368. I thought there were 369. I don't know. And you can see the means. These are just the descriptive means and standard deviations. This is for assertive, empathic, blah, 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 blah. Okay. Now here is our multivariate analysis, and of course the Wilks-Lambda. This is a multivariate F here. As the Wilks-Lambda's value gets smaller, your multivariate F will get larger. They're a function of each other. They're both multivariate tests. Peli's, Hotelling's trace, and Roy's greatest characteristic root is what it is. And it's power. So we do have statistical significance with the MANOVA. Here's the eta squared in terms of the MANOVA, a 0.53. That means 53% of the total variance in the multivariate variance is attributed to the differences between and among those underlying dimensions or characteristics. Okay, here's a test for sphericity. Okay, it's Mauchly's test for sphericity. The W test, Mauchly's W test. And here's the value. But the problem is the SIG is a probability value. This is an exact probability value. On assumptions, you don't want to reject the null hypothesis. You want that to be a 0.35, a 0.98, a 0.67, point something else. You want to fail to reject. That means we cannot assume sphericity. So, but we can handle it, okay, through the Greenhouse, Geyser, Hoytfeld, and lower bound, and I'll show you here in a minute. Okay, here if we could assume sphericity, we could use right here, and this would be our significance. It is significant. Now notice here when we're assuming sphericity, okay, if we could assume the degrees of freedom would be 3 for the denominator, the comparison among the dimensions, because you had 4, and k minus 1 would be 3, and for the error term, which is actually a quote unquote error term because it's action interaction, but do you see the degrees of freedom would be what? 1101. Now go back to the up here. Do you see this was 3 when we could assume it? The Greenhouse Geyser would be a 2.77. Hoyt-Felt would be a 2.8, and lower bound would go from 3 to 1. And notice here, if we on the error term, the denominator of the degrees of freedom, we had 1101, we would drop all the way from 1101 down to 367 for lower bound. And when you do that, that means your critical F value is going to be out much further in the F distribution, in the rejection area. So that means your observed, or derived F value is going to be larger to reject. But if you still can reject with those conservative degrees of freedom, you can violate the assumption, or you can fail to assume sphericity, and you still will not increase your risks of a type 1 error or alpha error. Okay, it's very clear. And the lower bound is very conservative. So when we make, and some of the graduate research assistants here are involved in a study where we're looking at the MMPI on 10 clinical scales, we can't assume sphericity. But we're going to report the usual degrees of freedom, then the conservative degrees of freedom on the summary table, and then the F values to see. So in other words, we're protecting even though we can't assume sphericity in terms of type 1 or alpha error rate. That's the reason for that. And lower bound is extremely conservative. But you can look over here, and any of these, we got what? Statistical what? Now the eta squared, here now, the multivariate, remember eta squared was much larger. The eta squared in terms of effect size, the efficacy of the results, 34.34, 34% of the total variance is accounted for or explained by the differences between and among those 4 underlying dimensions, those 4 underlying characteristics of women that are in leadership positions. That is not a real strong effect size, but reasonable. Okay? When you get up around 0.49, that's to me, that's a strong effect size. And you get much up there, really much higher than 0.7, it becomes suspicious, quite bluntly, okay? and the biological sciences, psychology, linguistics, nursing, biology, and education. Okay, so we're on a roll here. Now, so then we can go on down here with, here are the sums, type 3 sums of squares, degrees of freedom. So we could report the usual in one column, and in the next column, conservative. But we would select either Greenhouse Geyser, Hoytfeld, or lower bound. Here we're not interested in, well, we might be interested in, no, we're not really. We can't really fit a curve to it. But we can go all the way down here to look at, okay, here if you want to compare, remember this was assertive. The second factor, what do we call it? Huh? Empathic? Okay, okay, there is a difference, do you see? Between 1 and 2. There is a difference between 1 and 3. There's a difference between 1 and 4. Okay, the only one where there's no difference is between 3 and 4. The only difference, and now this is using the Bonferroni pairwise. Because our omnibus F was significant, now we wanted to find out if factor 1 was different from 2, factor 1 or dimension 1 is different from 2, different from 3, different from 4. Then there's a dimension 2 different from 3, dimension 2 different from 4, and it's 3 different from 4. All pairwise comparisons, you see. So, and the only one here that's not significantly different, because here's your, now these, when it says SIG, what they mean is a p-value. But these are actual calculated p-values. And you always go back and compare that with the original alpha that you set before you collected datum 1. After you wrote your research hypothesis or hypotheses, your null hypothesis or hypothesis, then you set your alpha at 0.05 or 0.01. Okay? So Halisa, if your life and my life survive, we set it at 0.01 because we don't want to commit a type 1 error, alpha error. Okay? If somebody else's life's involved, 0.35, whatever. Okay? Okay, because we try to protect against a type 1 or alpha error. And professionals and scientists always try to do that for 2 reasons. A, it's an honest error. Intellectually, scientifically, professionally, it's an honest error. But you've got that one time out of 100, that extreme quirk. You didn't mean to do it. You don't know you did it, and nobody else did it. Other people will take your findings and go back to their school district, their hospital, their clinic, their organization, their business, and apply your results, not realizing it's a type 1 error or false. A type 1 or alpha error is when your decision was to reject the null hypothesis when you should have failed to reject. And it's very serious. That's the first reason. That's A, because it'll inflict violence on society. A. B, other people will build their research off of yours. So you'll inflict violence on the applied body of knowledge, the basic, peer, and theoretical. They don't realize that it's a type 1 or alpha error. You will not know that, okay, until other people have independently replicated your study and all of them are failing to reject. Then you got that. Nobody knows that. You can go to a conference and you'll have somebody yell in the back of the audience at the person presenting, you committed a type 1 or alpha error. He or she does not know that. And does anybody else on the planet, okay? Until there's, and it's possible, highly unlikely, but it's possible. Okay, so now we're going to go all the way down here. We can see the profile in a minute. Okay, now see, in terms of being assertive, it was different from all of the others. Remember that? The only ones that were not significantly different were what? These 2 here. Now again, I do recommend on this one here, now don't trust these graphs, okay? On these computer software programs, they can be very misleading. I have a data set that I use with the first stat course. It's a 2-way factorial where assistant superintendent for schools in a state like in Austin, TEA or something, wants to look at passing on the scores on licensure exams or certification exams. And so they have male, female, then they have their majors where it's PE or vocational education, English or math, etc. Well, when you plot just a gender, it looks like this on the graph, it looks like there's got to be significant. You go back up to the Sumber table, not only is it not significant, the F value is less than 1, which theoretically is not supposed to happen. Okay, your derived F value is never supposed to be less than, cannot theoretically be less than 1. It can be that you violated something. Okay, so here's you can see the profile, but there was no difference between what? Factor, this is the factor 3, which was that self-confidence, or I forgot what it was. Positive and self-confidence. But there is a difference between, this one here, and in any of these 2 from 4 and 2 from 3, there's just no difference between underlying dimensions 3 and 4. But that's a graph of it. You see, graphing it. Now, so what we have done is we have taken a survey scale, and then this is true with any scale you're trying to build. It doesn't have to be a survey scale. We've looked at some of the psychometric properties and how that could possibly impact further things down the line. It's like it's a cascading effect, like a snowball, almost. So if you don't have your items, and I think Dr. Mills and I both are fully aware of this, if your items are not yielding variance, you see, and then the distribution of that variance, then the student gets to his final results and he or she doesn't have anything, and they feel very, very bad. We could have probably reduced some of that pain by doing some psychometric work initially. The factor analysis, again, we're looking at construct or theoretical validity. We didn't actually get to analyzing the phenomenon, okay, till after. Remember, we transfer into common metrics, common calibrations. That's still psychometric. That's measurement scaling kind of thing. When we did the profile analysis, we're analyzing the phenomenon. Another thing we could do is we could take those 4 factors. We could take those 4 factors and look at the salaries of those 368, or how many it was, 368 or 69 subjects. Their salary, like this, some will have high salaries, some will have average salaries, and some will have low salaries, bajo, you see. There'll be some variability in their salaries, and then we'd find the total variance on y, which equals 1. But then what we could do, and we don't have to use common metrics for this. We can use the raw scores, because the regression, the derivations on regression will take care of it. What we can do then is we can enter these as predictor variables. Each one of those dimensions or factors, predictor or independent variables. And in this case it'll be 4 of them. And over here we have our dependent variable, the variable of interest that the scientist or researcher is interested, the dependent variable, or a criterion variable. And you want to know how much of this variance in salary is accounted for or explained by the first dimension being assertive. The second dimension, what was it? Empathic. The next one was what? Positive. And remaining positive. And then this one was self-confidence or something like that. Self-esteem, self-confidence or something. We can find out, which you've got variables 1, we got factor 1, 2, 3, 4. We're entering now in regression analysis, but now we're starting to analyze phenomenon. Just like when we did the profile analysis, that's analyzing the phenomenon. Okay? The other thing we did, everything we did up to that was psychometric work, dealing with the psychometric properties, all the way to construct validity or theoretical validity. And so we can do a regression analysis, and we can find out Say, for example, if let's say our multiple regression coefficient turns out to be, you have y, which is your salary here, and x1, which would be assertive, and then 2 it might be empathic, and 3 was what? And this was self-esteem here. This was positive here. And let's say that the multiple regression coefficient came out to 0.70, then you could square that, and you would see that, okay, 49% of salary, whether they have high salaries, average salaries, or low salaries, is accounted for or explained by these 4 underlying dimensions of the administrator or the leader, the CEO of the company. And then you can do also standardized regression coefficients and find out which one of these variables and in what amount is accounting for or explaining this variance. In other words, the one who has maybe more of this here really does account for or explain more of that, you see. But this is actually analyzing phenomenon. The first part, what we did was psychometric, developing the scale. But if you don't do that, this is going to give you nonsense. A lot of people just want to jump. They just want to get their scores off of their survey. They don't know they had 44 items or how many they had, 14 or 22 items, and they just want to jump into the ball game. Also, it's not unusual for faculty and doctoral students who come in. Usually, and this is in medicine, biology, nursing, psychology, education, physiology, it makes no difference. You never enter more than 5, 6 factors in regression analysis. If you have more, like 22, like I got one now, she wants to do enter 22 of them, we need to do a factor analysis, a dimension reduction. Because your first thing, you're probably not measuring 22 different phenomena, okay? And then, so we need to enter domain and do like we did. But you don't have to transfer them all the way to common metrics. You can use the raw scores in here. Because the regression formula, the derivations, and regression, like on Pearson product moment, will take care of it. So then, and you can then analyze the phenomena itself. So that's, anyway, we made some steps. Okay. And you can also do comparisons. You can take, with, if you also, you could do a factor and administer that same 44 item scale to men that are in leadership, okay, CEOs, executive positions, and see the underlying, now this is kind of a psychometric thing, see if you get the same 4 underlying dimensions for them. Then you can compare, or if you get 5, but you can compare the factor structure and factor pattern. In other words, is that scale, now we're back to psychometric, is that measuring and tapping the same underlying dimensions in males in leadership positions as it is in females in leadership positions? Those are just different, but that's really more of a psychometric kind of thing. I don't know if this helps, but anyway. We got going today anyway. Yeah. Thank you for your help. Thank you for your help. You see, I didn't have any of those things circled or anything. And so you had them circled, right? You had them circled in red or something? So you knew which ones you wanted to. And then we saw why we had to delete some. And I've had people that work on their study for 2 years, and if they had done some pilot work, as Dr. Mills would say, before, they could have saved themselves a lot of heartache because they feel bad. So that we could compare each factor against each other factor. Because it was every subject going across. All 369 had a score on dimension 1. They had a score on dimension 2, and then a score on dimension 3, and a score on dimension 4. So you were observing each of the 368 subjects on all 4 dimensions that had a common metric. So we could look at the amount of whatever they had. Assertive, you notice, was quite low on them. But what was the second one? Was self-confidence or empathic was quite high. So that gives you it gives you a little, it's a descriptive thing. It's basically exploratory factor now describes what's underlying. But when we did the repeated measures analysis of variance, we saw the amounts that they had of each one. But in order to do that, we have to transform each one of those because now they're separate scales. So you could build separate scales now and name them. With those, you could build a scale that had 4 underlying dimensions, and you'll get their score on those 11 items for the first one, then the next 5 items for the next one that loaded here. So you would have a scale, and then you could give this to, say, if you were head of personnel or human resources, and you could see, hey, they fit the profile of a woman that's in an educational or CEO or leadership position in a hospital, organization, school, or thing. If you were head of personnel or organizational management or something like that, human resources. But you could build that literally into scale, and you could sell it, market it, okay? Sell it to people, make some money, patent it. Yeah. Pardon?
If they want it.
Yeah. Because you'll have it set up, you can have normative tables with common metrics so that you can take their raw scores and transfer in whatever metric it would be, but that's, you have to do some linear and nonlinear transformations to do that, but that's how you could do that. And you would sell a scale, market the scale, measuring, education, leadership. Women, in this case, have to be women in leadership positions, but you could use it. Okay.